Hi everybody, welcome to a new unit. Our unit today is going to be on matter, and we've got a lot to go through. A couple of housekeeping details. Just a reminder to use the pause button, use the rewind button. If we go through something and you say, gee, I really didn't get that, or I zoned out, or whatever, just go back, rewind it, and watch it again. Take notes. We will check to see them, so you have to make sure that you do them. So we're going to check them to make sure that you actually wrote notes on each of the podcasts. Right. One more thing, you're going to see some things in this podcast that are not tested on the worksheets. So just kind of as if you look at a worksheet and you expect, oh, if I just do the worksheets, I'll be fine on the test. It doesn't work that way. There's going to be stuff that's in the podcast that's not on the worksheets. So we expect that you know it, but we don't necessarily put it on the worksheet just because, what are we going to do? Have you just write it down again? You just wrote it in a note. What's the point? All right. What's the definition of chemistry? What do you think chemistry is? To you, pause the video, see if you can write down an idea of what you think chemistry is. I'm not looking for Webster's definition. I'm looking for what you think it is. All right. Definition of chemistry is it's the study of the properties, composition, structure of all substances, matter, and the changes they can undergo. Well, that is more of a Webster definition. Okay? Essentially what we're doing is we're looking at what makes up matter. You know, what's your PC made out of? What's a piece of paper made out of? What's water made out of? And we all know, I mean, you guys know what water's made up of, right? What is it? Yeah, it's H2O. All right? But when we think of H2O, what is H2O? Well, it's hydrogen and it's oxygen. Well, what does oxygen look like? Well, you're breathing it, right? You're breathing oxygen. And how about hydrogen? Well, hydrogen is something that is very flammable, and you can put it in a balloon, kind of like helium, and it's very light, and it tends to rise. But that doesn't look at all like water. These two over here, these are both gases. But when you put them together, they become a liquid. Interesting. Wonder why that happens. Well, that's part of what we study in chemistry. Right? That was good. I wrote all over that. Can you see how this is central to so many occupations? Right? So if you think of occupations, occupations might be, for example, anything scientific like a dentist or a chemist, clearly, of course, any kind of biology, you need to know chemistry, but you do things like you work in civil engineering and you need to understand the stresses that a bridge can take or that a girder can take, or you're building a house and how much stress can this wood take to manage to hold up the house. All of these have to do with chemistry. All right, the scientific method, let's go to that. You've all seen the scientific method before, this is nothing new, but very quickly I just kind of want to go through the steps of the scientific method and why we want to have a scientific method. Right? Do you recall why you might want to use a scientific method? See if you can remember that. Pause the video, see if you can come up with anything. Okay, so what is the scientific method? It's a way to answer questions about the world we live in. We often say, why is this true? It's something that is very logical. It's orderly, and it's so logical and it's orderly that it's repeatable. So when we're actually going and testing something, we can test it multiple times to make sure it really does behave the way we think it's going to behave. It's a systematic way to gather knowledge and or information. All of those things are true about the scientific method. And for me, it's a way to learn. So let's look at the steps of the scientific method. Typically, the first step is you observe something. You see something and you say, well, why? So you ask a question. Right? Now, sometimes the question happens first. And that's kind of like what Einstein did. He asked a lot of questions. Okay? But for most of us, we observe something, we state a question, and then we say, this is what we think, this is why we think this happened. And then we perform an experiment to see if it really did, and then we'll state a conclusion. So we might observe, for example, that one person's shirt is lighter than the other one, even though they bought them at the same time. So we'd say, why? So we form a hypothesis. Maybe John's shirt is lighter because his has been washed more. And so you perform an experiment. And maybe that experiment is simply asking Mom if she washed her shirt more. And that answer might be no. So you might form another hypothesis. Yeah, and by the way, you state a conclusion that my hypothesis was wrong. So now you go back and form a new one. Maybe he worked construction all summer. Oh, and then you perform an experiment. Did you work outside this summer? Yes. You ask the girl, did she work outside this summer? No. So your conclusion might be that, yeah, my hypothesis probably makes sense. All right. Now, Einstein had an interesting, very interesting life. He never performed experiments. He observed things, he stated questions, and he formed hypotheses. For example, he observed light, and he came up with a question, and he said, well, and I'm not going to explain this in the video, but he stated a question about light and said, could it possibly be that light always travels at the same speed? And we believe that is true. And he believed that was true. And he said, well, if that's true, then since speed is made up of distance over time, I can prove that time has to be relative. It has to change based upon the observer. And so he formed a hypothesis. He never performed an experiment to prove this. He let other people do that. Okay? And they actually did, and they proved that time is relative. We're not going to get into that today. If you want to know more, come see me. I'll be happy to explain it. It's kind of cool. All right. Let's talk a little bit about matter. What is matter? Think about that. See if you can come up with a conclusion. An answer for that. Again, not Webster's definition. All right. What is matter? Matter is anything that has mass and takes up space. So if I think of this pen, for example, right, it has mass, it weighs something, and it takes up space. Or I think of this glass of water that I have, it's a liquid, and it has mass, and it takes up space. Okay? If I have a gas, a balloon, for example, does it have mass? Does it take up space? Sure. In both cases, that's true. All right? So, matter is anything that has mass and takes up space. Now, I just talked about 3 of the 4 states of matter. Can you name them? Pause the video. Write down the 4 states of matter, at least 3 of them. Okay. The 4 states of matter are solid, liquid, gas, and plasma. Now, the 3 that we're going to focus on are solid, and liquid, and gas, because those are the ones that we can see every day and that we can actually play with. Okay? So let's think of those states of matter in terms of shape and in terms of volume. So if I take a rock, if I take a solid, does it have a specific shape? Is that shape changing, or is it staying static? Sure. The shape of the rock is staying still and it's staying the same. Does it keep up the same amount of volume? In other words, if I come back 5 minutes from now, a week from now, a year from now, will the rock have the same volume? Sure. It'll have the same shape and the same volume. Okay? So a solid has a definite shape and a definite volume, and it's not easily compressed. You're not going to go and compress that rock. Right? How about a liquid? Well, it definitely has a volume. Right? When you buy a bottle of Dr. Pepper, it's going to tell you how many fluid ounces it is. It definitely has a volume, but it does not have a definite shape, because if I turn the bottle upside down, even though all the liquid remains in the bottle, right, now all of a sudden up here, oh, that doesn't work, does it, Skip? Nope, that doesn't work. Let's try that. Okay, up here, this part is currently filled with air and carbon dioxide. Well, if you turn the bottle upside down, this is all going to be filled with liquid, and all the air is going to be down here. So that tells you the shape of the air is changing, the shape of the liquid is changing. So here, even though it has a definite volume, it does not have a definite shape. Okay? And also, liquid is not easily compressed. We'll talk about that in a second. All right? And finally, we have gas. Does it have a definite shape? I sure don't think so. It's kind of just floating around there. Does it have a definite volume? No, it doesn't have a definite volume either. It can expand or contract based upon what's around it. Okay, so it does not have a definite shape or a definite volume, and it's easily compressed. And we're not going to worry about plasma. Plasma is what's on the sun, and we can't play with that, so we're just going to not worry about that. Okay, so we're really focused on solid, liquid, and gas. So try this at home. Can you squeeze the bottle? Try squeezing a rock. Obviously, you can't squeeze a rock. Can you squeeze a bottle and compress the liquid inside? All right, I propose a lot of you are going to say yes. We'll take the bottle. I'm trying to write on my laptop. It doesn't work that way. All right, take the bottle, and you notice how there's some air up here? Get all the air out. In other words, fill the bottle right up to the top with liquid, and then put the cap on really tightly. Right? And then try and squeeze the bottle and see if you're compressing it. Then take another bottle, or empty all the liquid out of this, right, and put the cap back on and squeeze it. All right? I propose when it's a gas, it will compress easily. When it's a liquid, it will not compress at all. You'll deform it some, but you're not going to compress it. Right? And bottom line is, if you look at a rock, you're certainly not going to go and compress a rock. Okay? So a gas is easily compressible, whereas a liquid is not compressible. So why are gases easily compressible, whereas solids and liquids are not? Well, it all has to do with molecules, and you guys are all familiar with molecules. You've all learned about molecules way back when in like 5th grade and 6th grade and everything. So very quickly, and we're going to just kind of fly through this, in a solid, our molecules tend to be all next together really tightly, right? And in the liquid, they're moving around, but they're still really tight in together, really close. Whereas with a gas, there's a lot of space in between the molecules. In fact, there's a lot more space than what you're seeing here. All right, there'd only be one molecule inside the circle. In fact, chances are the molecule wouldn't even be inside the circle. There's a lot of room in between the molecules. And we'll talk about how to prove that later, but bottom line is that's your solid, that's your liquid, and your gas has a lot of space in between. So these molecules of a solid can't be compressed anymore because they're already tightly together. And these molecules in here, they're all real tightly together too. But these molecules over here have a bunch of empty space in between them. Yes, let me say that again. Empty space. So in between the gas molecules, there is nothing there. Empty space. I know that's hard to deal with, but that's true. All right, we have another term for gaseous state, and that's sometimes vapor. So we'll sometimes use the word vapor instead of saying something's in a gaseous state. And when we're talking about vapor, vapor describes a gaseous state of a substance that's generally a liquid or a solid at room temperature. An example would be water vapor, carbon dioxide vapor. Well, that's not true, but water vapor is a good example. All right, so what kind of properties does matter have? If I look over here, I have a pair of chopsticks. Right? So if I look at those chopsticks, what properties does bamboo have that make chopsticks a good use, make bamboo a good use for chopsticks? See if you can think of some. Pause the video, write a couple down, see what you think. All right, well, one thing is that they don't splinter very easily. Right, so you're not going to get a lot of splinters in your mouth when you eat with chopsticks. That's a good thing. They don't have taste to them. They don't have much taste at all to them. Okay, they don't smell, so you don't have an odor. They're hard. They're not going to break easily, and they're easy to split, so you can make these nice straight chopsticks. Right, and they're heat resistant. So unlike some woods, right, if you think of pine, for example, pine has an odor. Pine has a taste. Pine is definitely not hard. And pine is definitely not heat resistant. So that's why bamboo works really well. So, properties help us classify matter into different groups. So some properties of matter that we can think of is we can think of the property of density. How dense is something? Right? If we think of something like a metal, they typically sink in water. If we think of a gas, they typically float. Right? We look at mass. We look at volume, color, hardness. There are many, many more properties of matter that we can use to classify something. Properties are used to describe matter, and we can classify them as intensive or extensive properties. Now go ahead and pause the video right now and write down those two words because we're going to define them in a moment. Okay? So, what's an extensive property? An extensive property is a property that depends on the amount of matter in a sample. In other words, how much of the stuff do you have? So give me some examples. Right? In fact, let me give you one and then you can pause the video. Right? If I try and pick up a little pebble and I try and pick up a big rock, they weigh different, right? So the mass is something that is extensive. It does depend on the amount of matter in the sample. Right, so give me an example, some more examples of extensive properties. Write them down. Okay, so I told you that mass is a measure of the amount of matter the object contains. Another example is volume. How big is it? The bigger it is, the more space it takes up. Okay, that means that I have more stuff there. Those are extensive properties. Intensive properties, on the other hand, are just the reverse. Intensive properties say, I don't care how much you have, it's not changing. All right. So I have some bowling balls here, for example. And so an intensive property is a property that depends on the type of matter in a sample, not on the amount. So give me an intensive property of these bowling balls. Hopefully you came up with color. Right? It doesn't matter whether I have a very small bowling ball over here or I have a large bowling ball. All right? If it's blue, it's blue. All right? And that's all there is to it. If it's green, it's green. All right? If it's flame colored, it's flame colored. All right? How hard is the bowling ball? That's another example. Now, if I have two bowling balls, if I have two of these, they're going to weigh more. That's extensive. They're going to take up more room. That's extensive. But they'll still both be blue. That's intensive. They're not any more blue than they were before. If I have 100 balls there, doesn't matter. They're still not any more blue than they were before. Right? The hardness of a bowling ball, polyester versus polyurethane, is an example of an intensive property. How hard is this one versus how hard is that one? Right? That is something that doesn't matter whether I have 1 or 100. Okay. All right. So you need to know intensive versus extensive properties. All right. So intensive might be color. Intensive might be hardness. Right? Those are some examples of intensive properties. All right. So our summary of this podcast is you need to be able to define chemistry, not a Webster's definition, but something where you understand what it means. You need to be able to understand and use the scientific method. You need to be able to define matter. You need to understand the properties of matter and understand extensive versus intensive properties. Right? So go ahead, go off and work on your worksheet. If you have questions, I'll see you in class. Have a good day. Oh, by the way, did you pause the video? Did you take notes? If you didn't take notes, please go back and take notes, because that's something we're going to check before we let you take your unit test. Okay? We will check for notes.